Sounds
All right.
good. Awesome.
Right.
Thank you.
All right. I see Jackson, Mira, Arturo. Good welcome, guys. Good morning. I'm going to go ahead and get started today. And if you could mute your mics, that would be great. That way we kind of avoid the feedback sound. But if you do have any questions, feel free to unmute it and speak up, especially when I'm sharing the screen, because I can't see easily what you're looking for. Good morning, Cooper. So we'll go ahead and get started. The first thing I want to do is I want to, celebrate how we're working on it. This Code HS, we kind of threw you a curveball. I know it's not what people signed up for. We said that we're going to do programming because, this class is a CTE, a career and technical education class. So we wanted to sort of hold the value up of that. But obviously, we don't all have Inventor or PCs at home. The POE class doesn't have the robotics and the VEX kits at home. So you guys have been really adaptable and adjustable to the Code HS. And from a teacher's standpoint, it's going really, really well. In all three classes, I maybe have 3 students out of all of them who aren't doing anything, who aren't showing on work. There's some students that are, a day or so late, and I'm absolutely fine with that. But by and large, when I check Code HS, I'm seeing work being done, and it's being done well. There's clearly you're learning and you're getting the basics of those things. So I just wanted to tell you, good job. There's a lot of teachers are struggling with getting input and work done. In the engineering class, I feel really lucky because you guys are getting it done. I do want to just say one thing. When you are doing Code HS, I was looking at it just again this morning, and you are given in those little activities specific problems to solve, and that's what this class is all about. It's not really about JavaScript as a language. It's about you using the computer as a tool to solve problems. So I want you to try to make an effort, when you're doing those little activities, and we'll review them in a moment, to get all of those little boxes either blue or green. When they're yellow, I go in and I look at them to see, hey, did they get it more or less right? But it should be green if you've solved the problem the way that they've intended you or they've asked you to solve the problem. So I'll go to those here in just a second. The other thing is when I have interacted with students that are struggling, I'm suggesting, and students that are going through it relatively quickly, I'm suggesting that when you watch those little videos about new ideas, that you keep some notes. So I actually paused the video and I have a little notebook. Here are my notes for the last one. This was graphics. So you guys aren't on graphics, or I haven't assigned it yet. Some of you skipped ahead, and that's fine. What I struggle with is not necessarily that the problems that they're asking us to solve are so difficult. It's that I just watched the video and my short-term memory is such that I don't remember the syntax. How do I structure that command in JavaScript? And having those notes of what the person did, the man did in the video, actually makes it go faster when I'm able to do that. And then I can also show you some resources on Code HS, which I'm going to show you right now. So I'm going to share my screen. If I start talking and you don't see the screen, someone unmute their mic and let me know. And what you should see right now is my Code HS, and it looks similar to you, right? We did most of Carol, so we're done with that. I asked you to pick a challenge, a Carol challenge for aspect 3, and a lot of you did that. And then we're working our way through here, JavaScript and graphics. This is what I like to see for students. That makes things really easy for me. If they're all green, I know you got it. If they're yellow, I check it. And if you have the basic idea down, if it's an indentation problem, I typically don't worry about that too much. But I do want you to solve the problems here. So I'm going to pull one up and just remind you what these were about, because it's what you're going to have to use in your aspects. So 3.2 is variables. And just to remind you, right, what variables was about is you were asked to kind of learn about different variables and putting them in there. So the activity that you were supposed to do was what they call the daily activities, where you have these strings and these variables, and you're just going to print the lines. When I hit run code, it should come out like that. When I hit check code, it gives me all of those greens, right? So we're going to do that today. You will need to use variables in the aspect 3 part of our assignment. If I go back here and, oops. The next part was user input, and we're going to do that as well. So we want the computer to prompt the user for some information, and the activity you were asked to do for that one was the dinner plan activity. And most of us got this. Some of us were a little bit off base. What the intention was is that it's asking you for input. So we're defining 2 variables. I called mine name and time. And the name will be a string, and the time would be an integer, read integer. And when we hit run, it should prompt you for that. So we put in a name, my name, we put in a time, and then the output says, what time would you like to meet for dinner? And it says, hi, Todd, I will meet you at 5 o'clock. So again, you're going to be prompted for some input in the aspect 1 today as well. And then finally, the last activity before we're going to assess here was 3.4. And that was basic math in JavaScript. Probably to students has the most boring name, but to a physics teacher, man, I really love this section. It gives you a really nice concrete example of how great computers are. I won't show you both, but I'll show you one of them. One of them was calculating the cost of t-shirts. The other one was running speed. And if I had the majority of questions come in over the last week, it would be based on this. So I'll just show you how mine was structured. First thing is I defined a fixed variable, and they go over this, right? A variable that won't change throughout the program. Sometimes I might refer to them as a conversion factor, is capitals and underscores. So I don't expect to have to change this. Minutes to hours. And the reason that's important is because they asked you to input a distance run in miles and a distance run in minutes, thinking none of us are like marathoners and running for hours at a time, but then compute and report a speed in not miles per minute, but miles per hour. So let me just show you how I structured that. So first of all, I made an unfixed or a fixed variable, and I just called it minutes to hours, and it's 60. The variable I called distance, and that kind of makes sense. I have it read in as an integer. So my program won't allow you to add like half a mile. It would be 3 miles, 4 miles, 5 miles. If I wanted a decimal, I would put float, read float. And the text that prompts you, it says, congratulations on your workout. How many miles did you run today? And then the next variable will be prompted, and I define that as time. And again, that's an integer. And it says, wow, that's great. How many minutes were you running? So now I'm going to input minutes. And here's where that calculation or that conversion comes in. The speed is going to be a distance divided by time. And the time would be the time that was input as the variable divided by 60, right? If I put 60 in, it's going to compute then 60 divided by 60 is 1 hour. So it'll compute distance divided by time in hours. And when I hit run, I'll show you how it works. If I put 5 miles in, and just to check to make sure my math is working, I'll put 60 minutes in. It should report 5 miles per hour. And it says, might be hard for you to read that, your average speed was 5 miles per hour. Good job. So that's one thing also I want to point out in, while we're doing the math here, is it's also important to check the math, just like in class, right? Just because you put numbers into a calculator doesn't mean the answer is correct. You may tell the computer to do one thing that you think is correct, and it's not doing it. So just because a computer is doing it, make sure that you put in the right algorithm or the right math. So I'm going to pause there for a moment. Are there any questions, guys, before we move forward? I'm going to explain how I want to kind of incorporate all of those things together into this third aspect, or this aspect of Unit 3 anyways. Any questions? Okay. I'm going to share the screen again then. I'm going to go to the classroom. And again, I'll use engineering 3, our third period, as an example. Just reload this. All right, so today you're going to be pushed forward. I might have to, it should have been popped up by now. Let me just check another class real quick, guys. I might have to make a change right after this meeting for you, but it will be done. Well, let me just show it to you what it is, and I'll figure it out afterwards. As soon as I get done with the meeting, I'll make sure that this is available to you. This is what you're going to be asked to do. So this is the document that will guide us. And what I'm looking for is basically the skills of 3.2, 3.3, and 3.4. Prompt the users for input, perform basic mathematical operations, and print lines containing text, strings, and numerically calculated variables. You're going to write a real simple program that tells us some real basic mathematical things about circles. How are you going to do it? You're going to use your sandbox again. And just like last time, except you're going to use graphics, and we'll title it Graphic Aspects 1. And of course, instead of selecting Carol, you'll select a graphics template, right? And I got you started here. So it says, begin your program with the following code. This determines a permanent value pi. So we'll call it capital PI, and we're not going to change the value of pi. So it'll be 3.14. And I have it started. You can just copy that straight away to start with that. This is what I want you to do, though. The program should perform the following task. It should prompt the user for their name. It should prompt the user for the radius of a circle in centimeters. Calculate the circles. Now you're going to use the math part, right? The diameter in centimeters, the circumference in centimeters, and the area in centimeters squared. So based on that radius that you put in there, you're going to write a function and a variable to calculate the diameter, the circumference, and the area. I'm trusting that you have the faculties. If you don't remember those definitions of the equations, they're relatively basic, and man, you can get them almost anywhere, right? So that's the task in there. Here's what I want the output to look something like, right? The output should look like this. Now, I just screenshotted this off of my window, and this is what I'm looking for. Here's the prompt, and it said, hi, Todd. So Todd was a variable. It was a name. The values for your circle are printed below. The radius of the circle you entered, and this was just the one example, 67. So 67 is a variable. It could be anything. The diameter was calculated on that radius. It's 134. Should make sense, right? That should be twice the radius. The circumference of the circle is 420.76 centimeters. So that was calculated using circumference. And the area of your circle is 14,095 square centimeters. And again, that was calculated based on the input radius. So the program should correctly calculate those things, and correct is important. Remember, check it. Have a calculator and check the output from your program to make sure it's doing it correctly. If it's doing it correctly once, you could assume it's going to do it correctly over and over again. The program should include descriptive comments, especially where new variables are defined. So comments are really, really important, especially when you're sharing programs. And when I'm trying to evaluate what your program is doing, those comments are really helpful. So I'm not going to show you an example of this particular program, right? That's your task. I'm going to show you an example of a very, very similar program that's doing the same thing, but not with circles. So I'm going to pull up my sandbox. And I'll pull up this one I called sample graphics one. Now, this is a different task, but I want to show you it's not really a long program. So it's commented here. And what this program was read to do is the simulation I was thinking about is, let's say you wanted to tile a room, or you wanted to get some new flooring for your house, and you need to figure out, like, how much do you need, how many boxes and things like that. One of the first things you would need to do is you need to enter in or figure out what the area of the room is. So there are a few things then that are fixed variables, and they're titled and underscored. So the tiles per box, I just said, let's say there's 20 tiles per box. The cost per box would be $50, you might assume, $50 per box. And the variable is area per tile, and I just said each tile has maybe 2 square feet in that case. The first part of the program then prompts you for information about the size of the room. So I called this one room 1, and it says read in integer, read in one dimension of your room in feet, right? So, we know area is length times width, so maybe this is length. The second variable prompts the user for what I called room 2. Read integer, enter in the other dimension. So if I'm talking like a 4x5 room, it'd be 4 and 5 that I'm putting in here. Now these are variables and calculations. So this one says variable area, just calculates the area. Room 1's measurement times room 2 measurement. That's like length times width. The next one then calculates the number of tiles I would need. It's the area divided by the area per tile, which was up here. The next variable calculates the number of boxes I would need. Takes number of tiles and divides it by tiles per box. And then the last one calculates the cost. The number of boxes times the cost per box. And then this is just code to print out text that's useful to the reader. What am I looking at? The total area of the room you wish to tile is, and then print the value, right? Area, what is that area value? So on and so forth. So I'll just run it for you real quick and show you how simple it is. It says, hello, enter in the dimension of your room. So let's just make it simple so we can check. Let's say one is 5 feet. Hello, enter in the other dimension. So let's say it's 4 feet. So I'm expecting the area to be 20. And then here's my output down here. So it says, the total area of the room you wish to tile is 20 square feet. The project will require 10 tiles. The project will require a half of a box. This will cost $25. So the mathematics of this is probably a little bit more sophisticated than the circle example I'm giving you, but the structure of the program and how you're going to work and maybe print lines out will be very, very similar, right? So at that point, I'm done, going on and on about what I want you to do. Do you guys have any questions about what's expected or what needs to be done? Feel free to unmute your mic and let me roll. If you don't have any questions, or you don't have any specific questions for me, you're welcome to bug out and get started. For whatever reason, that link with the document of what to do wasn't pulled up. I'm going to go put that on. As soon as I get off here, I'll put it on everyone's classroom so you could use that as a guide. I'm recording this, so as soon as that video processes, I'll put that up. But unless you have a question for me, guys, it was good seeing and talking to some of you today. Let me know if you have any questions here. I'll stick around for a bit if need be. If not, have a good day, guys.
Bye, Mr. Hennings.
Bye.
Thank you, Mr. Hennings.
You're welcome, Renner.
Inventor. I'm going to work on the inventor stuff probably later this week.
Okay, well, give me, like I said, let me know if you got questions or need clarification.
Okay, sounds good. Thank you.